Okay, here we go. So we just finished making the unit circle, and now we're going to learn how to use it. And so we see what we learned way back in geometry, and we used it in Algebra 2 trig as well, SOHCAHTOA. We know what it stands for. Let's say we have this angle theta. We like to use theta to represent angles. It's just the same thing as x, except that it's a Greek letter, right? And so let's say we want to know what is tan of this angle theta. So what's the measurement of, the tan of theta? And so what we do is we use SOHCAHTOA, and it says tan is equal to the opposite side over the adjacent side. So if the opposite side had a number, right, had a length, we'd put that on the top, and the adjacent side had a number here, we'd put that on the bottom, and we'd be like, great, that's what the measurement of tan theta is. And so you're like, well, what does that have to do with our unit circle? Well, let's go ahead and look at, how about we look at pi over 3, all right? So pi over 3 is, a spoke in our unit circle wheel, and our coordinate point there is what? 1/2, comma, root 3 over 2. And we talked about what this coordinate point means, but let's go ahead and do it a little bit more here. So to get to this point right here, this coordinate point, we had to go over and then up. Ooh, okay, I went over a little bit too much, but you get what I mean. And so this angle right here, right, this is my initial side. That's my terminal side. I'm going to undo that so I don't have too many things going on. All right, so we've got an angle here, and let's make it thin. Here's our angle. Our angle theta is pi over 3, okay? That's the measurement of this angle. That's the spoke, and the spoke is the terminal side, and then we've got our initial side. Okay, so wonder if we were looking for, well, let's just start with sine. Okay, what if we were looking for sine of this angle theta? Actually, we know what the angle is. So let's put it, sine, our angle is pi over 3. Well, let's see. Sine is going to be the opposite side over, the opposite side over hypotenuse. And I'm trying to rush this, and I'm just going to slow down. So let's see, the opposite side is here, and let's stop and say, well, what is the opposite side? This 1/2 means to get to this point, first I had to go over 1/2. So my x value right here is 1/2. To get to this point, I then had to go up root 3 over 2. Okay, and that's my y value. But it's also within this triangle, if I'm looking for my opposite side, right, my opposite side from theta is going to be root 3 over 2. So let's go ahead and, we'll just keep going. My opposite side is root 3 over 2, and so we're going to put that, and now it's got to be over our hypotenuse. But the cool thing about our hypotenuse is that every single spoke in our unit circle is a radius, another radii is the radius of this circle, and it's the unit circle, so all our radiuses are 1. So sine would be root 3 over 2 over 1, right, which we don't need that because that's just going to be root 3 over 2. So that's how we know, actually, we can use these coordinate points as a shortcut. Because if sine is opposite over hypotenuse, then sine in the unit circle is always going to match up with our y value, right? And the same thing, cosine would be, cosine is going to be what? Adjacent. So cosine of pi over 3 is going to be the adjacent over the hypotenuse. Well, what's my adjacent? 1/2. So we have 1/2, and then over hypotenuse is 1, so that's going to be my cosine. So cosine of pi over 3 is 1/2, and then sine of pi over 3 is root 3 over 2. All right, so let's just jot this all down on our next step. So we already know sine is going to match up with the y value, cosine is going to match up with the x value. Let's go ahead and put this. Every coordinate point that we see on the unit circle, our first number, of course, is going to be our x value, what that's equal to. Our second number is going to be the y value. So we use the unit circle to just do a quick little bam, sines y, cosines x. Let's go ahead and remind ourselves how tan and the rest of them relate to sine and cosine. So sine and cosecant they're reciprocals of each other. So if sine is equal to y, cosecant is equal to 1 over y, all right? So another way to say that, let's go back to here. See how sine of pi over 3 is equal to root 3 over 2? Well, if we wanted to do cosecant of pi over 3, we could say 1 over root 3 over 2, but instead, we're just going to flip these two, because that's what a reciprocal is. We take a fraction and we flip it. And so cosecant would be 2 over root 3. Okay? Now, could I do 1 over root 3 over 2? Sure, but I'd end up with 2 over root 3. All right? So if we know what sine is, we know what cosecant is, we just flip it. So let's write that, flip sine. All right, same thing with cosine. If we know cosine is x, then secant is going to be 1 over x. If cosine is 1/2, then secant is going to be the flip of that, which would be 2. All right, so we'll go ahead and let's write down in our notes that secant is the flip or the reciprocal of cosine. So that's why I'm writing it both ways, right? 1 over x, but also the flip. We already know that tan, let's go back to tan in SOHCAHTOA. Tan is opposite over adjacent. And so in using the unit circle, it's going to be our y over our x, right? We also know tan is sine over cosine. So sine is y, cosine is x, okay? Now, cotan is also 1 over yx, like we wrote it here. But look, because tan is in fractional form, we can flip it, and cotan is x over y. So we're going to use this in our next assignments. I think you have a delta math and you have some mazes. It's going to ask you different values. And so all we're doing is this. We are using, let's see. Oh, we're going to talk about tan. Let's look at this unit circle before we talk about tan. We are using the unit circle. Okay, this one doesn't have the coordinate points. But we're using the unit circle as like a gimmick. It's a gimmick to answer questions pretty quickly. Some of you learned last year to just keep making those special right triangles. You can keep doing that. It's going to be a little slower. But you still, even if you do that, you still have to memorize how the bow ties work together. We're going to talk about reference angles next class. All right, let's talk about tan. So before we can talk about tan, let's go ahead and fill in these coordinate points in the first quadrant. And so once again, we talked about the, the everything, all the coordinate points, have the 2 underneath, so we're going to put that there. Oh, we feel like we're almost done. And then we talked about when we read, we start on page 1, and we start at the top left of the page, so we put a 1 there. And then we just work our way down, 1, 2, 3, and then we work our way back up, 1, 2, 3, and then we remember, wait, shouldn't there be some square roots? We don't put our square roots on 1 because square root of 1 is 1. We put our square roots on 2 and 3. Okay, not bad. We can memorize that. And so let's talk about tan. So tan, if we just memorize some things, we're going to have a little easier time with tan. So let's talk about tan of pi over 3. That's going to be our y value. Root 3 over 2 over our x value is 1/2. And so the 2's cancel out, and we end up with tan of pi over 3 is root 3. All right, I want us, let's see, I don't know if I can, let's see, I'll just do root 3. All right, I want us to know that tan of pi over 3 is root 3. So we don't have to keep doing this part over and over again. All right? Tan of pi over 4, easy peasy. Root 2 over 2 over root 2 over 2, the same thing over itself. We know that's going to be 1, right? And then lastly, let's do tan of pi over 6. And so tan of pi over 6 is going to be the same thing, the y value over the x value. And so the 2's cancel out. We end up with 1 over root 3, but no, that's not good enough. We have to rationalize the denominator. And so we end up with what? Root 3 over 3. Now, I'm going to show you a cute little way to remember this. Obviously, tan of pi over 4, easy peasy, it's 1. Pi over 3, there's a 3 here. Let's see if I can do a different color. There's a 3 here. and then there's just 1 3 here, all right? Here, for pi over 6, there's 6, and what adds up to 6? 3 plus 3. All right, so the one with the 2 3s goes with the 6, because 3 plus 3 is 6. The one with the 1 3 goes with the 3. All right, that's my little thing. All right, have fun. Look, I know that you can use your unit circle, like just stare at it and use it to use delta, to do your delta math problems and do the maze problem, but don't do that, because the reason why I'm giving you practice is so that your brain can get used to, okay, what do I need? And it quickly does the first quadrant, and it figures things out. I want you to be doing that, especially for you people that are going to go on to calculus. You need to know the unit circle inside and out. And for those of you that are going to be taking a test, that's nice too. All right, thanks for joining me. See you in class.